electric field intensity due to a line charge. So what was the expression for E? E is equal to rho L by 2 pi epsilon 0 rho. So this was the expression, right? So we found that the electric field intensity due to a line uh, gradually decreases or inversely proportional to the distance rho from the line to that point, right? Perpendicular distance rho. So we used a cylindrical coordinate system here to derive, and that is why we have rho here. Okay. Now, today we will be discussing about electric field intensity due to a sheet of charge. So, can anybody tell me what are the parameters we will be considering here? What is charge density we have to consider? Which charge density? Surface charge density. Very good, Prajwal. That is rho. Yes. Okay. Then which coordinate system? For point charge, if you consider equidistance pointers, it becomes a sphere called spherical. If we consider line, if you consider equidistant points, it becomes a cylinder. That is why we go for cylindrical coordinate system. Now, from sheet of charge like this, if you consider equidistance point, what shape you will get and which coordinate system is better? For point spherical, for lines cylindrical. If I consider all the equidistance points from the sheet, yeah, I'm getting again another sheet, right? So this is a rectangular sheet. So we go for rectangular coordinate system or Cartesian coordinate system. This will be easier for us to analyze, right? So we got two conditions. So in the last class, if you remember, we took a point away from along the z-axis, and we found the point P in the x or y axis or any axis. So z dash, z prime, and this is dz prime. So like this we have to, and we have to assess the electric field intensity at point P. Similarly, today we will be considering a sheet of charge. So, you know, here this is the x-axis, red. This is the x-axis. This is the y-axis, and this is the z-axis. Now I'm considering a point here. Say consider a sheet of charge which is of having infinite area. It is not finite. It will be having an infinite area. Okay. So can I get the total charge from of this sheet? We discussed about rho s, right? What was rho s? Rho s was dq by ds. So if I want to get to dq, I have to do rho s ds, right? So I have to calculate the entire area and substitute that in the expression that 1 by 4 pi epsilon 0 dq by 4 pi sorry, here it is r square ar cap. So this is what we are doing, right? Clear? Now, if we have to do this integration, the ds may be consisting of two things, dx and sorry, dy and dz. So I have to integrate along y-axis, integrate along z axis. That will be difficult because I have to do two types of integral. Can we simplify this in another way? Like, can we take a line charge? Sorry, I'll draw a perpendicular line here like this. Okay, this line has a width of dy because it is in the y-axis. Okay, and dy prime I will represent, and it is y prime away from the origin. Okay, now what is the line charge density of this line? Because we have surface charge density rho s, and we know the width of this one as dy dash. Okay, and we don't know the z limits. So what will be the line charge density? Can anybody tell me? See, this line has a width dy dash and surface density rho s. If I multiply rho s into dy dash, what it will be? Rho s into dy dash. Is it the charge? Can I say it is the charge? Charge is dq, right? Dq, if you want a small portion, I have to take a dy and dz. Okay. Now, ρs is equal to, oh, sorry, dq is equal to ρs into dy into dz, right? Now, what is this ρs into dy? If I consider this entire length, can anybody tell me what is that? Yes, Sanket, very good. That is the charge per unit length, because into length gives the charge, right? D cube by dz gives what? Rho s dy. We have discussed this one. This is nothing but rho l. So we know if you consider this as a line charge, and you know the rho l as rho s into dy, then let me erase this one. So I took a line here. Sorry for the drawing. Okay, I took a line here which is y dash away from the origin, and the width of this one is dy dash, and rho s into dy dash is rho l. Okay, now I want a point P here. So this is along the x-axis. So what is this length? If I am taking an arbitrary point, can I mark it as x? The coordinate will be x comma 0 comma 0, because it is in the x-axis itself, right? And this point is 0 comma y dash comma 0. Now, can anybody tell me what is this length? This length is x dash. So if I draw that, if you visualize from the top, this length is x dash, this length is y dash. So I'll erase and draw, show here. Okay, so like this, in the sheet, I took a point line here, which is y dash, and here I am taking a point x. So I want this distance connecting these two. What is that value? Can anybody? The length. Anyone is there? What is this length? Yes, Kushi. Very good. Any other answers? Yeah. Good, Akriti. Because this is a right angle triangle, so the length here it will be root of x square plus y square, right? Is there any answer? Okay, is this clear, right? X, y dash, x square plus y square. Now, uh, if I consider this angle as theta, okay. Now we'll go for the original image like this. Okay, I'm taking a line here. This is a line which is y dash away from this one, and the rho L is equal to rho S into dy dash. Dy dash is the width of this one. Okay, we took a point which is away from the originator point x, and this is the line joining. Let me mark this angle as theta. Now, what is the direction of E? So this will be the direction of DE. Why I am considering it as DE? Because I am from the entire sheet I am only considering one line. Then I have to extend for all the values, right? So can I split into this as two components? One along the x-axis, that is DEX, and another along the y-axis, that will be DEY. Now, for the same line here, y, which is y dash away, you can consider another y dash in the other direction, minus y direction. There will be one line, right, which is having the same line charge density, rho s dy dash. And the field due to that, let me mark in another color. Field due to that will be so this is the line joining these two. So the field due to that will be in this direction. I think this is visible, right? Is this visible? Okay. So field is in this direction, which also can be split into two components. One is X component, another one is the Y component. Right. Now, what happens to the Y component? Uh, Due to this line, the Y component is in the minus Y direction. The same distance we have another line, the Y component is in the other direction. In the last class, we discussed how the Z component cancelled. In the same manner, you have the Y components cancels. Is this clear? How the Y components cancels in the case of sheet of charge? Okay, if you take anywhere a line, say a similar line will be there in the other direction, which gives a Y component in the opposite direction. So you have only the left part is in this direction, x direction alone, because y and plus y and minus y cancels, only x component will be there. So if I want to DE, which is nothing but only DEX, I have to integrate, right? But what is DEX now? Okay, so we got something like this. Here, this is the y dash point, this is the x point, okay, and we had a vector which connects this one, that is DE. So that vector has two components. One is along the x-axis, so DEX, and another one is the y component, that is DEY. We found that DEY has equivalent another component which will be cancelling. Only DEX will be there. Now this angle is theta. Now if that angle is theta, this angle will be theta. So DEX is which component? Adjacent component or opposite component? DEX is equal to, what is DEX component? Adjacent or opposite? If you are not responding, I will call the names. Is the screen visible? Okay, that question is clear. Now my question, DEX is X component or, sorry, DEX is the adjacent component or opposite component for angle theta? Yes, very good. Adjacent component. So adjacent component is what? Cos or sine? Yeah, cos. So can I write it as dx is equal to dE cos theta, right? dE cos theta. Now this is the line with the line charge density rho L is equal to rho S into dy dash. And I want dE and cos theta. Okay, then we have to integrate for the entire variable which we are using. Now, can somebody tell me what is the value of mode dE? So what is dE? This vector dE is what? Electric field intensity due to what? Due to X. Huh? dE is the electric field intensity. Okay, due to what is the source here? A point or a line or sheet? Yeah, very good. That is line charge. So we know the expression, right? What is the expression for line charge? dE. It is rho L by 2 pi epsilon 0 rho aero cap, right? So this is the direction. Aero cap is the direction. Now what is mode dE? Magnitude of this one. There won't be aero cap, only this component, that is rho L divided by 2 pi epsilon 0 rho. So this is the rho. This length is rho. Now, can anybody substitute the values like what is rho L? Rho L is rho S dy prime divided by 2 pi epsilon 0 rho. What is rho? We discussed this one. If this is the right angle triangle, this distance is square root of x square plus y prime square. Okay. So we got the value of dE. Okay. Then what is next? So we have to get the value of dEx. So what is dEx? This one. Mod dE cos theta, which is rho s dy prime divided by 2 pi epsilon 0 root of x square plus y square. Now cos theta is there, which doesn't have x and y component. So can anybody get the value of cos theta in terms of x and y? Cos theta in terms of x and y prime. So this is theta. So what is cos theta here? Adjacent divided by hypotenuse. So what is adjacent parameter here? X divided by, is that x by y prime? That is tan theta actually. Adjacent by, sorry, cot theta. I want cos theta. Yeah, x by rho, not x by y prime. So what is rho here again? X root of x square plus y square, right? So which is uh, rho s dy prime divided by 2, sorry, I'll write in the new page. So dEx is equal to rho x rho s dy prime divided by 2 pi epsilon 0, and you have square root of x square plus y square 2 times. So I can remove the square. So it will be x square plus y square, y prime square into x, right? So this is the dEx. Now how to get the value of Ex? Ex, we have to integrate. So integral, uh, which are the constants here, which I can take outside. Let me write this first. Rho s dy prime x divided by 2 pi epsilon 0 x square plus y prime square. Okay, so which are the constants which I can take outside here? Rho s is a constant, x is a constant because I am integrating with respect to y prime, and 2 pi epsilon 0 x square plus y square is together, so I cannot take x square here. So only these many terms I can take. Rho s x divided by 2 pi epsilon 0 dy prime divided by x square plus y prime square. So what is the limit? Limit for integral for y. For this sheet, I am considering along the y-axis. I am considering. So this is the sheet. So from here to this end. So what is this end? Along the y-axis, what is the minimum value? Along the y-axis, what is the maximum value? Since this is an infinite sheet. Yes, very good. That is minus infinity to plus infinity. So this integration is like uh, is is this like dy by a square plus y square, where a is x, or integral dy by y square plus a square. So what is the dy prime divided by y prime? Okay, so what is this integral? You might have studied in integration, integral dx by x square plus a square. Is just a tan inverse x by a, or something else is there? X square plus 1 has tan inverse x, right? Instead of 1, we have x square plus a square. So what is this integral? Sanket, your answer is almost correct, but one more term is there. Integral dy prime divided by y prime square plus a square, or x square. Anybody has answer? Yeah, 1 by a is also there. So here instead of a we have x. So rho is x divided by 2 pi epsilon 0 is a constant. So 1 by x, because we the constant is x here, 1 by x, 1 by a, tan inverse x by a, x instead of x we have y prime by x. Limits minus infinity to plus infinity. Since x is constant, we can cancel them initially itself. So what is the value of tan inverse infinity minus tan inverse minus infinity? What is tan inverse infinity? Rho s by 2 pi epsilon 0 into tan inverse infinity 90, or pi by 2, minus tan inverse minus infinity, tan inverse minus infinity minus pi by 2, right? So pi by 2 plus pi by 2, that will be pi. So which is rho s by 2 pi epsilon 0 pi. So pi cancels. The final term is rho s by 2 epsilon 0. So this is Ex, right? So what is E? E is equal to EX AX cap, because only X component we have. So that will be rho S by 2 epsilon 0 AX cap. This is the final answer. So what is the inference from this expression? How it is related to the distance? So the distance is X, actually the point where we took is X. Does this value depend on X? No. So it is independent of distance, right? So electric field intensity due to a shield of is a constant, because rho s is constant, epsilon 0 is constant, 2 is constant. So this is a constant, and it does not depend on at which point you are evaluating, how much far away from the sheet. If you are evaluating anywhere, the electric field intensity will be constant, right? So since we took the sheet along the y plane, along the y axis, or x is equal to 0 plane, we got the expression as ax cap. What if we have to take the sheet in the other plane? For example, here instead of x is equal to 0, if I take y equal to 0, so my sheet of charge comes along the y axis. So where I have to take a point? I have to take a point here, which will be y away, and I have to consider x prime as the value. So the direction of the electric field intensity again will split into two components, x component and y component. The x component will cancel due to this line and this line, but only y component will be there. So if the plane is y equal to 0, the electric field intensity will be, so it depends on the plane. Here ax cap came because, what is the reason why it is ax cap? Because we took the sheet in x is equal to 0 plane, or along y axis, or parallel to y axis, right? If y is equal to 0 plane is used, what is the direction of electric field intensity? Rho s by 2 epsilon 0. What will be the unit vector here? Can anybody tell me what is the unit vector along this direction? Which direction it will be? Yes, very good. AY cap. And it can be, it depends on which direction. Here also in the previous diagram, if I am considering along the positive axis, it will be AY cap. If I am going for the other direction like this, if I am considering in this direction, here if I am considering, it will be minus AY cap. Here if I am considering, it will be plus AY cap. So there is two direction for a sheet. So similarly, in the third case, what is the third case? Z is equal to 0 plane, or Z is equal to constant plane. Any Z is equal to constant means parallel to Z axis. So XY plane. So what is electric field intensity here? Rho S by 2 epsilon 0 AZ cap. Correct? So there are three possibility, unlike other two cases. So can we summarize all the three cases? Point charge, what is the electric field intensity? E is equal to 1 by 4 pi epsilon 0 Q divided by R square AR cap. We are going for spherical coordinate system. Line charge, what is the electric field intensity? It will be rho L divided by 2 pi epsilon 0 rho aero cap, and sheet, the electric field intensity is what? Rho s by 2 epsilon 0, right? So these are the cases. Now we will solve one or two problems. Just note down along with me. Okay, first we will discuss a problem regarding field of line charge, which we discussed in the last class. So, infinite, note down the question. Infinite uniform line charges, charges of 5 nanocoulomb per meter lie along the x and y axis in free space. Find question A. Find electric field intensity at PA 0, 0, 4. Can you try to solve this one? The expression is electric field intensity is rho L by 2 pi epsilon 0 rho aero cap. So this is the expression. So can you try once? The question is two line charges are there. One is along the x-axis, both negative and positive, and another one is along the y-axis. So you have to find the electric field intensity at a point uh, in the direction of at a point 0, 0, 4. So how to do this question? So along x-axis means this red line here, right? In this line you have the first charge, and the second one is along y-axis. So let me mark each cases here. So the first one is along x-axis, so something like this. Another one is along y-axis. So this is, so two line charges are there. I want to find the electric field intensity at a point here 0, 0, 4, right? 0, 0, 4 means only z axis. So in this one, so I want the rho, which is the perpendicular distance from that point to the lines. So what is this length? Can anybody tell me what is this value of this length? From 0, 0, 4 to this point. What is the length? This length, perpendicular distance. That is the rho. Rho equal to how much? 4, correct. So rho equal to 4. Then so the electric field intensity will be due to this line, which will be upward, and due to this line also, which will be upward. So they are added up, right? So what is E? E is equal to, so we'll come here. E is equal to rho L by 2 pi epsilon 0 rho A rho cap. So actually total electric field intensity is due to Ex plus or E1 plus E2, right? So what is the value of E1? Rho L by 2 pi epsilon 0 rho by, so rho L is how much? 5 nanocoulomb divided by 2 pi epsilon 0. So we know that 1 by 4 pi epsilon 0 is how much? What is the value of 1 by 4 pi epsilon 0? 9 into 10 raised to 9. Okay. So 1 by 2 pi epsilon 0, how much it will be? 1 by 4 pi epsilon 0 is 9 into 10 raised to 9, means 1 by 2 pi epsilon 0 will be half of that, right? So 4 point, that 18 into 10 raised to 9. No, sorry, 2 times. Sorry, correct. Yeah, 2 times of 4 pi epsilon 1 by 4 pi epsilon 0 is 1 by 2 pi epsilon 0. So it will be double. So it will be 18 into, so this value is 18 into 10 raised to 9 into rho L is how much? 5 nano. So 5 into 10 raised to minus 9 divided by rho is 4. In the case of first line, similarly, in the case of second line also, 18 into 10 raised to 9 plus 5 into 10 raised to minus 9 uh, divided by 4 again. Okay, 1 by 2 pi epsilon 0 is 2 times, not half times. Okay. So what is the total value? 10 raised to 9 cancels. So 18 into 5 divided by 4. 90 plus 90. 90 by 4 plus 90 by 4. What is the final value we'll get? 45. Yes, very good. 45. What is the direction of, what's the direction? AZ cap. So 45 AZ cap. Correct. That is the correct answer. Okay. So is this clear how to find the electric field intensity due to a line charge? Just a substitute. Only you should know the value of rho. Rho is nothing but the perpendicular distance from that point to the origin. Okay. No, origin, not origin, that line, the perpendicular distance. Okay, so in the same question, can we do a B part? So B part is find uh, the electric field intensity due to, okay, another point we'll consider, that is 0 comma 3 comma 4. Can you try 0 comma 3 comma 4? Okay, try yourself. What will be the electric field intensity at a point 0 comma 3 comma 4? So this is the point, and the charges lie along the red line as well as the green line. How to calculate? So it comes like this, two lines. Here it is the point. So you need to know, if I'm considering x-axis is the first line, L1, and y-axis the second line, L2. Here, this is L1, the green one is L2. Okay, this is x-axis, so L1. Let me take this as L2. Okay, so what is the perpendicular distance from L2? That is easy. So this is the point 0, 3, 4. What is this coordinate? And this is the perpendicular distance, right? So what is this distance now for line L2? This is the y coordinate 3. This is the z coordinate 4. So what is the perpendicular distance for the line L2? So this is the perpendicular distance. How much is the perpendicular distance from line L2? Directly upward. Okay, if it is difficult you to analyze this point, there is an easy method. Like we have what is royal. Royal is equal to sorry, not royal. E is equal to royal by 2 pi epsilon 0 rho arrow cap, right? So if the point is given in Cartesian coordinate system as x, y, z, then what is the value of rho? Rho is equal to root of x square plus y square, right? And what is a rho? A rho will be rho divided by magnitude of rho. So rho is actually x ax cap plus y ay cap divided by square root of x square plus y square. So if I substitute that here, E is equal to uh, royal. So what is royal divided by 2 pi epsilon 0 x square plus y square, because you have x ax cap plus y ay cap. Okay. So now can you find the value using this equation from first line as well as the second line? So you can always use this one if you have a difficulty in finding the perpendicular distance. Use this equation. So can you substitute the values E1 and E2? Okay, this is in the case of, sorry, again I have to make a correction here. This is in the case if the line is in along z axis. So just again I will write all the cases. E is equal to rho L divided by 2 pi epsilon 0 x square plus y square into x ax cap plus y cap if line is in z axis. Now, can you tell me what is E? It will be root 2 pi epsilon 0 x square plus z square into x ax cap plus z az cap. So, in which case this is the expression? Can you tell me in which case we are using this expression? In the sheet we had three conditions, right? Like that here also we may have three conditions if we are using Cartesian coordinate system. So in which case we are using this expression? Yes, if the line is in y-axis, correct. Then E is equal to rho by 2 pi epsilon 0. Can you tell me for line in x-axis what is the case? Here it will be y ay cap plus z az cap divided by x square plus z square. Okay, done. So our problem is at point 0 comma 3 comma 4. The line 1 is in x-axis. So what is E1? E1 is equal to rho L by 2 pi epsilon 0 into, since along x-axis what expression I have to use? Y ay cap plus z az cap divided by y square plus z square. So what is the value? Rho L is 5 nanocoulomb, so 5 into 10 raised to minus 9. 1 by 2 pi epsilon 0 is 9 into 10 raised to, sorry, 18 into 10 raised to 9, and the remaining values are y ay cap. So this is x y z. So 3 ay cap plus 4 az cap divided by y square plus z square, that is 25. So simplify this expression. Now what is the E2? E2 E2 is along which axis? Y-axis. So y-axis means the expression is rho L by 2 pi epsilon 0. Along y-axis means x ax cap plus z az cap divided by x square plus z square. That is why you have 5 into 10 raised to minus 9 divided by into 18 into 10 raised to 9 y ay cap, sorry, x ax cap, x is 0, so 0 plus z az cap is 4 az cap divided by 0 square plus 4 square. Okay, so 4 will cancel, so simplify this expression. And what is the final E? Okay, final E is E1 plus E2. Is this clear? So this is how you have to find the value of E. So simplify this expression and find the value in your notebook. So we'll wind up the class here with attendance.